At this moment, our entire solar system is orbiting the center of the Milky Way at 828,000 kilometers per hour. Despite that speed, it takes us 230 million years to complete a single lap. The last time we were in this corner of the galaxy, dinosaurs were just beginning to appear on Earth. Most diagrams show the solar system as a flat 2D grid. In this model, the Sun and all the planets sit on a level surface known as the ecliptic plane, circling like marbles on a plate. This makes sense to our brains because on Earth, gravity gives us a clear orientation. There is a ground beneath us and a sky above us. But in deep space, those directions don't exist without a reference point. By relying on a flat map, we ignore the massive three-dimensional environment surrounding us. There are enormous structures and mysteries waiting directly over our heads and beneath our feet. The flat model fails the moment we look at the math of our neighbors. Mars orbits the Sun at a 2-degree angle relative to Earth's path, while Mercury sits at a 7-degree tilt. Further out, the tilts become extreme. Pluto's orbit is inclined at 17 degrees, and the near-Earth asteroid 3200 Phaethon travels at a 22-degree angle to the rest of the planets. Halley's Comet is the ultimate outlier. Its orbit is tilted at 162.3 degrees, meaning it travels in the opposite direction of the planets, far above and below the main disk of the solar system. To navigate this, scientists use the Galactic coordinate system. They draw a 90-degree line straight through the Sun to establish a north and south pole for the galaxy, creating a vertical Z-axis for the solar system. This reveals that the solar system isn't a plate, it's a 3D sphere. To understand our true place in the cosmos, we have to look at what lies along that vertical axis. The first thing we encounter moving vertically is a massive cloud of dust. Billions of years of asteroid and comet collisions have filled the inner solar system with fine particles that drift far above and below the planetary plane. Moving further out past Neptune, between 30 and 50 astronomical units from the Sun, we reach the Kuiper Belt. This is the home of icy dwarf planets like Haumea and Makemake. Beyond that is the scattered disk. Here, Neptune's gravity has flung objects like Eris into chaotic paths, forcing them into orbits with inclinations of 45 degrees or more. The further we move from the Sun, the more the gravitational order of the inner planets vanishes. Objects here are scattered across three-dimensional space in every direction. At 200,000 astronomical units, roughly 3.2 light-years away, we find the Oort Cloud. Astronomers believe this is a spherical shell made of trillions of icy bodies that completely encloses the solar system. Protecting the planets within this shell is the Heliosphere. The Sun shoots out solar winds at 400 to 800 kilometers per second, creating a massive magnetic bubble that keeps the interstellar medium at bay. We have physical proof of this vertical boundary. In 2012, Voyager 1 crossed the upper roof of this bubble, and in 2018, Voyager 2 crossed the floor below the ecliptic plane. Earth isn't just sitting on a flat surface, it is protected by an active 3D shield that maintains the environment required for life to exist. Leaving the Sun's influence behind, we enter interstellar space. Here, we must expand our map to a scale of 1,000 light-years. Our solar system is currently sitting inside the local bubble. This is a 1,000 light-year wide cavity filled with hot plasma at 1 million Kelvin. Millions of years ago, a series of supernovas exploded in this region. The resulting shockwaves blew away the surrounding gas and dust, leaving this empty void behind. We are currently sailing through a smaller, localized cloud of dust within this void, called the local interstellar cloud, which will take thousands of years to cross. Our solar system is traveling through a vast pocket of space cleared out by the remnants of ancient, dying stars. To see the largest vertical structures, we must look at the center of the Milky Way. Here, a supermassive black hole, known as Sagittarius A star, anchors the entire galaxy. In 2010, the Fermi Gamma Ray Space Telescope discovered two massive balloon-like structures erupting from this center point. Known as Fermi Bubbles, these gamma-ray structures extend 25,000 light-years directly above and below the galactic disk. They are likely the result of an ancient eruption from the central black hole. These are the most energetic structures in the Milky Way, and they exist entirely outside the horizontal plane where most stars reside. All the planets, stars, and gas clouds we can observe account for only 15% of the matter in the galaxy. The remaining 85% is an invisible substance called dark matter. Dark matter acts as an invisible scaffolding that permeates the entire galaxy. This field extends far above and below the galactic plane, providing the gravitational strength needed to keep the Milky Way together. The galaxy rotates so incredibly quickly that without this dark matter shell, the stars would simply fly apart. It is the primary force maintaining the structure of our 3D cosmic home. When we stop looking at space as a flat map and start looking up and down, we see that Earth is part of a complex, three-dimensional system of massive shells and invisible forces. Subscribe to stay tuned for our next episode, where we explore the recent discovery of life on Mars.